Hello everyone. Uh, Today we will see what is convolution operation, what is convolution neural networks, and convolution neural networks are being applied for self-driving cars, or like it enables the machine to see the world, like from the history of everything. Take this diagram, right? This one, actually this is a research done in 1950s by some biological researchers. The research showed like they kept a cat in they have taken as a cat, and when they showed certain edges like this, no, like if they show this type of edge, certain neurons get fired, and when they show different type of edges, certain pattern neurons firing was happening. When they show this edge, this kind of firing was happening. So so like it made them think at that time, okay, when we see some object, certain part of the neurons are getting fired. Fire in the sense like it sparkles. So what if we can apply this based on a computer? We know that neural networks and multi-layer perceptron and everything. Like here, when we say fire means what it actually, you have a neuron like this, right? When we say firing actually means, like, let's say a neuron like this, simple neuron. When we say this neuron is more active, when someone says generally like, okay, this neuron is more active, what does this actually mean is like, the weights to this neuron, right? The weights to this neuron, right, is higher in number. Let's say a neuron weight can be between 0 to 1. Okay, when we say this neuron has is firing means, here it can be like 0.8, 0.7, 0.9. So weights to that particular neuron are higher, so we say this neuron fires more. Like this biological inspiration of convolution neural network, when they saw cat's brain, they showed certain edges, certain patterns, and according to that the firing was happening. So people may, at the time this is was stopped, okay, they stopped it, like, okay, by using certain patterns, certain things are happening like that. Now we will see like what is convolution operation. Okay, uh, let's take a matrix, something like this. Okay, this is like set, let's take some matrix. Okay, and then in convolution we have a kernel. We'll say that in term as kernel or filters. Okay, it can be any matrix. Okay, it can be any matrix. Let's take this matrix as, okay, 1 2 1 0 0 minus 1 minus 2 minus 1. Okay, this is like what convolution operation is like. We take this matrix, let's see, we take this number. Okay, we take this number, multiply, like this is of 3 cross 3 matrix, right? Here we take only these 3 cross 3. Okay, we multiply 0 with 1, 2 with, set according to the position we multiply everything. Okay, we just multiply. Okay, this is 0 0 0, this will become 0 0, and this will be multiplied with minus 255. Okay, and here also we have minus 255. Okay, and this can be like 510. Okay, this will be like 1024, I guess. Okay, here you will have only one value, 1024 or something. Okay, not 1024, it will be like some number, okay, 2, okay, we'll get one number. The main objective you can see is like we have taken 3 cross 3 matrix, okay, and then here also we have taken 3 cross 3 matrix, and we applied convolution operation, and we are getting a single output, okay, single output. This is an important thing, okay. And then after this we take the same kernel, okay, and we do this for here, okay, for this part, like this matrix, okay. If we do this here again, I think we will get the same operation, okay. And then here enter again, next iteration here will come here, okay, and here also we can see like, okay, and then here, okay. This is what convolution operation is like. We have taken everything and we are convolving from here to here, okay. Like we are taking certain part of the matrix, and here also we have whatever is the kernel size, we are taking that, and then we are multiplying every number according to its relative position, and we are getting single output, okay. This is what convolution operation is, okay. Just for example, I'll show something. These are like input image, okay. This is the input image, and then this is the kernel. You have seen the kernel 1, right? We are just convolving to everything, and output is same. So when we take Gaussian blur, this is the kernel for Gaussian blur. We can see the image is somewhat like blurred, right? And you can see here there is this is a kernel, and we apply this kernel on this input image, and you can see there is a picture differentiation. Like here this image is much sharpened, and this is the operator for edge detection. Like, so if you take this kernel and we convolve with the input original image, you will get an output image like this, okay. You can see in this output we can see somewhat edges and everything. These kernels are done like, if you take general image processing, these kernels are fixed kernels. People found research and they came up with these kernels, okay. These are fixed kernels, okay. This is like another, like, this is one example I'll show. Like here you can see like this is image. Image will have 3 channels, RGB, okay, red, green, and then blue, okay. And we have kernels. You can see this is the kernel, like the shadow part is there, right? That is kernel. We are moving every operation, and then we are getting the output, okay. Now, like, the general term is like everyone understood, like what is a kernel, okay. Like in a convolution you have input image, and we have a kernel, okay, and we do the convolution operation, and we get output, okay. If the image is 2 dimensional, grayscale image means it's a grayscale image, you will have black and white. So generally in a grayscale image you will have values between 0 to 255. If you take any image and then take any grayscale image or something, you try to zoom it, okay, you try to zoom the image. Each value is known as pixel, like this pixel, this pixel, this pixel, okay. When we say like the images of 180 into 180p means this is the dimension of the image, like this is consider the image as a matrix and each cell as a pixel, okay. So the grayscale will have 0 to 255. If you take a like normal image, you will have 3 channels RGB, okay, RGB, okay. This is like the dimension is 3, okay. This is RGB image, okay. When we say training a convolution neural network, what does that actually mean is like here you can see these operators, right? These operators are fixed operators. We don't know what are the operators and everything. So we know these are fixed operators. When we say training a convolution neural network, we initially fix these operators to certain value. Okay, we initially fix these operators to certain initialization. Okay, after fixing these operators, we pass it to some dense layer or something, and then we compute the loss function. Okay, when we compute the loss function, we back propagate it. Okay, and then we update the values in this kernels. Okay, so here the machine learning model is trying to say which value the kernel should have. That is what we are training the convolutional neural network means usually. Okay. Another one operation is like max pooling. What max pooling is like, you have an image, right? Let's say you have a matrix something, okay, so you have 5, 6, 7, 8 something. When you do max pooling of 2 cross 2, what this is like, you take whatever is the maximum element in this matrix and you just replace it with 8. Okay, this is what max pooling is like. Okay. You take this is here they have this is you try to see the image like here this is a Lord Ganesh photo is there, okay, and they have applied 2 cross 2 max pooling. So after applying 2 cross 2 max pooling, we get the image like this. Here you can see there are some edges, right, like some edges, and you can see these edges. Here these edges will be somewhat highlighted here. The reason for that is when the kernel which goes to this part, it will take maximum of here. So when we take maximum value, this part which will get highlighted. This is one feature extraction of by max pooling, okay. Another like you try to understand, when we have a matrix, we take some maximum element value and then we pass it over here, okay, and we have this as x. One normal doubt is like, how do you back propagate in max pooling? Like when you take the maximum max pool of 2 cross 2 or something, we are taking only these values and we are getting to the next stage. When we say when training a neural network, we have to do back propagation and we have to update the weights. So in max pooling layer, the weight updation will happen to this number only, to this place, like irrespective of here it can be any number, okay, like 5, 6, 7. Let's say here it was 8. After max pooling, you came here it has 8. So when next weight updation happens, weight will get updated only for this 8 position only. It won't get updated for 5, 6, 7. It will be remained as base with this. This is what max pooling does. Okay. Like as we can see that input image, and then we are going to next, we are applying some kernels and everything, so the size of the image may get reduced, like okay. The general formula is like, if you have input image which has n into n and it has channels like this, okay, let's say you have a kernel, okay, which is have k into k and it also has channels. What will be the output is will be like, there are two edge cases, like you take this kernel and we are moving the kernel, right? If we move the kernel one step means you are applying a stride is 1. If you are moving twice means you are applying stride 2. Okay. And another one thing here, like when you take a matrix, this number and this number may not be, it will not be same. So when it comes to edge cases, okay, some information we may lose. Okay, this is what known as padding. Like if there is a kernel of size, let's say input image is 5 cross 5 and the kernel is 3 cross 3, okay, 5 cross 5, right? One, two, three, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. When this 3 cross 3 kernel, when it comes to this place, it won't have the number to multiply from here, right? So in this case, we will apply a value of 0 here, okay, like this. Okay, we'll apply value of 0. Now you can see after applying a 0, this will get matched. Okay, this is known as 0 padding. Okay, this is known as 0 padding. When you say when we apply 1, this is known as normal padding. Okay. So these are like when you have a convolution operation has two parameters, stride and padding and kernels. You have an input image and you have a kernel. When we apply convolution operation, the output image you will get will have dimension of n minus k plus 2p, your best, right, plus 1. Okay, this will be the output dimension. Okay, output dimension. Okay, this is normal. Okay, this is the formula. Okay. Next we'll see like LeNet architecture. LeNet, it got released in 1998. The authors were like Jan LeCun. They used MNIST dataset. MNIST is the handwritten dataset from, it will have like 0 to 9. Okay, 0 to 9 numbers will be there. Like it will have all the handwritten digits of every person, like of every number. Okay. You have an input image and you have a 5 kernel. You have 6 kernels. Okay, you have 6 kernels. So since you have 6 kernels, you will have 6 feature maps. 1, 2, you can see here you will have 6 feature maps. After feature maps, after from this stage, subsampling means like mean pooling. We have seen max pooling, right? we have if you have a matrix, you take what is the maximum element, and then you give that. This is called max pooling. And when you say mean pooling means we take all the mean, like x1 x2 x3 x4 means you take x1 plus x2 plus x3. You take that mean and then you give it. This is what subsampling is. Okay, and then again after subsampling you can see the size reduction will be there, like you have like same 6 features map but the dimension has got reduced. And then again you can see like we apply convolution operation of 5 cross 5 kernels. There are 16 kernels, so you'll have, even though if you have 6, at output you will be having 16 only. Okay, 10 cross 10 of 6. The one important thing to note is like the number of feature map in this layer will be determined by the number of kernels you apply here. Okay, number of kernels. Okay, if you have 62 kernels means you will have 62 feature maps. And then again they are doing subsampling of 2 cross 2 kernels, and then after that we are getting 5 cross 5 convolution, and then 16 features map you are getting. And here you can see like they are applying 5 cross 5 kernel convolution. If you apply 5 cross 5 convolution on a 5 cross 5 convolution, you will have output 1 only. Like you have a 5 cross 5 matrix and then you are applying 5 cross 5 kernel size means you will get output 1, only 1. So after getting 1, there are 120 kernels, so you will get 120 numbers, and you have fully connection layer. At last you have 10 neurons. Like okay, you will have 10 neurons. So this 10 will represent like each for 1 0 2 9. Okay, 0 1 2 3 4 9. Okay, you apply softmax function. Like what softmax function will do, like it will try to make the value between 0 to 1. Okay, 0 to 1. You will have x, let's say you have a pattern softmax of x is equal to, let's say you have softmax of x e power x. You take that x value and then you sum it over all the remaining edges. Okay? So this is what softmax function is. Right? It will give a value probability between 0 to 1. If it gives a value between 0 to 1 means you can say that you can determine the probability matrix. Let's say if the third neuron has a probability of 0.9 means the number will be 3, since like third neuron. Okay, this is AlexNet MNIST dataset. It was by Jan LeCun. He was known as father figures of convolution operation. Like if you at the early stages, like one interesting fact about Jan LeCun is like he invented convolution neural network, and then many people made a huge amount of money. Like he has a celebrity status. Like if he walks on China, Japan, everyone will come and get autograph from him. Like he has a huge celebrity status. Okay, but many people have made huge ton of money by using convolution operation and everything. So but one interesting fact is this is not like a educational perspective. After that he was teaching in NYC, and then he was a lead researcher in Facebook, and now he is in Meta. Actually he was applying for like a higher position. The reason he applied is like he was not getting enough salary. Okay, he was not getting enough salary. Like he invented convolution operation. Okay, and he was not getting enough salary, and the reason he applied for enough salary, he told is like he was unable to bear his son's medical expenses or something. Okay, this is one interesting fact. Let's summarize. Like you have convolution operation, where you have a input image of n cross n and you have a kernel. We go to each kernel, each side one by cross, and we are getting one output, okay, and we are writing the whatever output here, okay. So it will be like passing from one like this, it will be like straight, and then again you can see like there will be huge number of multiplication will be happening, okay. One interesting, like many people consider max pooling, right? Max pooling or any pooling, the default, like in Keras and then in TensorFlow and in PyTorch, everywhere the normal max pooling will have stride of 2, okay. When you have a stride of 2, let's say you have input dimension of 4 cross 4, you have a stride of 2 means the output you will be getting, mostly it will be like half, like you will get 2 cross 2, okay. But if you take both max pooling and convolution operation, you take a convolution operation, you are applying, and then you are getting one output. Similarly also, even in max pooling, you are taking the convolution operation and we are getting the same one output, okay. Generally when people say, like when the network passes through a convolution max pooling operation, the number of the dimension of the matrix will get reduced half. It's not the case actually. Both these operations are performing same only. The output you are getting one, and then you are convolving it and you are predicting here, okay. This is convolution max pooling. And another the reason convolution neural network is, like you have seen these operators, right? The Gaussian, blur and everything, they are fixed kernels for edge detection or something. But when you are saying detecting a face, the face will have different features, right? So at that case we don't know what is the kernels and everything. These values are unknown. So we are trying to find that values. That is what training a convolution neural network means. Okay. See you in the next video.